Hi guys, good morning, good evening, good afternoon from wherever you are watching us from this planet Earth. Well, today we shall discuss this. It's a DOL, direct online. Just one contactor, one overload. You can see one relay there. Yeah, it's a very simple circuit. And we have used a smaller enclosure. Normally, I usually use height 500, 400, and depth 200. But in this case, I've used 400, 300, and 200, and 300 depth. 400, 300, and depth 200. Yeah. That's why I've tried to squeeze everything that I need there. The connections will come direct here to the MCCB. This one is MCCB. MCCB, you can see 20 amps. My LCB is 4000. You see, I've just looked. I've used same color. I did not consider about the color code. It's 3-phase. Jumping from there, going into the trunking, going down here. Then I've joined here. Then they are going out there. The control for the neutral also from here and live from here. Then I'm supplying my transformer there to 20, and outside I'm getting 24. My relay there is also 24 coil. That's why I'm using the transformer. This transformer is just having this relay and these lamps. My lamps here, there, 24 volts also. Yeah. So it's a very simple circuit. Very simple. Actually, it is just self-explanatory, and we have one selector switch there. So we shall focus. Let's focus on our drawing here. Actually, I think I've never done DOL video. I think I've never done that. Yeah. But for today, let's start with this one here. So this one is my circuit, the control circuit diagram. Just like I have explained, it's a simple circuit. Since the live part is coming through the MCCB, from the MCCB to the ELCB, then there is the 220 which is going to the relay. The moment this relay will be energized here, it will supply our contactor. The neutral also is coming through this part, the ELCB, supplying the transformers, the primary side of the transformer, and also going direct to the coil of the contactor. So we have here the transformer. It will step down from 220. From this side, I have named it 220. This one I have named 220/0, which is supplying the transformer there. And this other 220 here, from the relay to the coil of the transformer, we named 220/1, something like that. So once I step down here, also you have to pass through the fuse. Then from the fuse, I'm coming out as 1. The 1, it will go to the overload 9596. It's a normally closed contact. Then from there, I'm going to through the selector switch. Outgoing selector switch number 4. Number 4 is going direct. It's hand side, yeah. It's going direct to energize the relay. When the relay is energized, it will close here. The 220 will energize the coil of the contactor. This side is the outer side, yeah. The outer side, which is 3 here, is going at my connector here. Then once somebody loops between these two, then you're going to complete the circuit and energize the contactor. So it's as simple as that. And my number one, you can see my number one also going to the contacts of the contactor. Yeah, number one. Yeah. Then from number 7 side, you can see the normally open part, and number 8 is the normally closed. So the number 7 is going to show our relay is running, and number 8 is showing our contactor is stopped. Like in this case, yeah, you can see the red showing it is stopped. If I select hand side, yeah, the contactor has energized, and number 7 is getting the supply to this lamp that is to stop, and that one is for trip, just in case I trip manually, which I'm going to do now, and then you'll see. As you can see, I want to trip it. It is in run. It's indicating that it's running. The contactor is on, so I can just trip it here. You see this position? Yeah. I just test by pushing this side, and it is stripped. So our lamp is indicating it is stripped. I can do the reset here. Okay. And how did this? You can see the overload is 1.6 to 2.5 amps here, and I have selected around 2 amps. So how did I come up with selecting 2 amps? Okay, the motor is a small fan, a small exhaust fan for a kitchen, and actually it is 1.1 kilowatt. Okay, this 1.1 kilowatt motor, how did I come up with the amps? It's a very simple calculation, which I have I'm showing here. You can focus on my drawing. So you can see for the single phase, if it is a single phase, but in this case it's 3 phase, yeah, you can see it's 3 phase. In case it is single phase, it's just power is equals to voltage times current. But also I can consider the power factor, which is 0.8. Yeah. If at all I calculate power, and for my case of single phase, 1.1 kilowatt is equals to 220 times the current, which is denoted by I. Then I have to convert from kilowatt to watts. I multiply by 1000. I'll get 1100 watts. 1100 watts divided by 220, which is our voltage here for the single phase. I will get 5 amps. But in case I'm considering the power factor, maybe I have the capacitor bank, or yeah, then I expect my amps to go lower to 4 amps. Okay, in my case this one is 3 phase, so it is equal to power is equals to voltage times current times the root 3 times the power factor. So 1.1 kilowatt is equals to 400 times the current, which is denoted by I, times the root 3 because of the 3 phase, times the power factor. So I convert that from 1.1 kilowatt to wattage, which is 1100, is equals to 400 times I times 1.73 times 0.8. So 1100 is equals to 53 times I, which is the current. So in this case, what is I? I is equals to 1100 divided by 553. So I get 1.1 amps. Okay, I get 1.1 amps. So, and that's why I have selected this overload, 1.6 to 2.5. I've selected around 2 there because the maximum current is 1.1 98, which is almost equivalent to 2. So in case it was a star delta, our overload there could have been smaller. Our overload there could have been smaller because I could have expected this current to be divided between the main contactor and the delta contactor. So in case it was on star delta, but in such a case, but in our case here, the motor is so small, just 1.1 kilowatt, so we cannot go for star delta. Normally DOL is from the lowest kilowatt up to 4 kilowatt. You can comfortably run your motor on DOL. But as you go to 5.5 kilowatt, you opt for a star delta. So that in that case you'll have three contactors. One is the main with the overload. The second one will be the delta contactor and the star contactor. In that case, if at all this one, in my case, this one was star delta, the current could have been divided into two, so I could have opted for a smaller overload, and I would have set maybe at 0.9 amps there, yeah, okay, at 0.9 amps or 0.95, yeah, something like that. So, yeah, now another thing, you have seen the calculation. So you can see a calculation is there, and in case maybe your motor is in horsepower, 1 horsepower, you'll find it is equivalent to 0.746 kilowatt or 746 watts. Yeah. Why the horsepower? Because before the Industrial Revolution, they were using horses for the mills and almost for all the duties. They were using horses, and the motors came to replace the horses after the Industrial Revolution. So they were estimating the size of the motor is working in the place of how many horses, because maybe one horse could handle this kind of work for 1 hour, and this motor is doing the same thing. So that's why we have 1 horsepower. One horse was replaced by a 0.746 kilowatt motor. Yeah, that's how they came about it. Okay, thank you guys. Yeah, see you next time. Technically, Dhanyawad.